Okay, now that we have talked about writing CSVs, this is really common. Text file CSVs, like I said, I spend at least a third of my time working with text and CSV files, especially to reformat them for different purposes, making them usable. There is one example of, and all of these are for vector data. 90% of it is probably for point data. Once in a while, polylines and polygons. We'll talk about that a little later in the semester. But there is a raster file format that's really interesting. We don't really use this format much, but it is the easiest way for you to see how raster data is handled inside of a GIS package. So this is called the grid ASCII file format. It's another format from ASCII. Thank you, ASCII. But it is open source and it's well supported, and it's pretty easy. It's a text file. So here's a file. Literally the contents of an ASCII grid text file. First, you have n columns and n rows. You probably already guessed that that's the number of columns and the number of rows in the data. Here's the data down here, and you can see there's 1, 2, 3, 4 rows of data, and then 3 columns, or 3 values per row, separated by a space. And the spaces are very important. Those separate each of the values. So since this is raster data, you can see we have a raster that's 4 rows high by 3 columns across, which is not very usable, but it's easy to look at as opposed to if I had a raster here that was 1,000 by 1,000 pixels. Okay, so then notice that we have the lower left-hand corner, and you might recognize that as a longitude, and then the X component of the lower left-hand corner, and then the Y component of the lower left-hand corner. Different raster formats identify different corners, but the bottom line is if we've got raster data, okay, like this, somehow we need to reference it to the Earth, right? We've got to have some kind of coordinates that say how this is referenced to the Earth. The most common is to take 1 or 2 of the corners and identify where they are. So like this lower left-hand corner down here is -105.41. So now we can pin that to the Earth. Now that's not enough to fully georeference the image, and we'll talk more about this later. This format uses cell size, okay, to get the rest of the information. In other words, we know that this pixel is at -105.40.1. We also know that this pixel is then 100 degrees in this case, because this is geographic data, above that, and then 100 degrees and 100 degrees across, 100 degrees across. So the spacing between each of these pixels is set to 100 degrees. Now again, this isn't a real spatial data set. It's one that we can play with and look at. And then there's also a no data value. In other words, a mask or a transparent pixel, -9999, which is very common, especially with Esri products, to use negative numbers with lots of 9s in them. And you can see here we've got some no data values. All right, so this is kind of cool because what you can do is you can just take this and you can insert this into a software editor, text editor like Notepad++, one I use all the time. We can save this, and I'm going to go ahead and save this as a test file, and I'm going to call it ASCII. Now ASCII is very important because that's the file extension for the grid ASCII file format. So you've got to do .asc, and often you have to set this to all files so it doesn't make it .asc .txt. That would be annoying. Okay, but then we go ahead and do a save. And while we're on that topic, I should also show you something that sometimes you won't see the actual file extensions. Microsoft likes to hide them from you to make things easier. Well, when you're a developer, that makes them a lot harder. If you go to one of your folders and go to the View tab and then go Options, Change Folder and Search Options, and then go down to View, you will then see Hide Extension for Known File Types. You will want to uncheck this because this is going to hide extensions for things like .txts or CSVs, things the operating system knows about. We need to see those, okay, because you need to make sure that it really is a .asc file. Okay, now, if I have ArcGIS open, okay, I can take that file and I can drag and drop it or load it by adding data. and ARC's not really fast, especially ArcGIS Pro, this little tiny raster file. So it's kind of ridiculous how long this is taking. I actually paused that because that took way too long, which is a little bit strange. But now we can zoom to layer and ta-da! All right, now this may not initially make sense, but you can see that here we are off the coast of Africa, which is where 00 in lat long is. And we can zoom to the layer, and then we can go and get our data. We should be able to see that our data, let's see how I can do this, that over there. See, okay, that we've got these different values. The maximum value we have looks like that's 34, and you can see that's its brightest pixel. Oop, or 37 over here. So these two are almost white because those are the maximum values. Then we can see there's a minimum value here of 12, so that's our black pixel. And then we've got minus 9999, so these are our transparent pixels, and then these are different levels of gray. So this data is actually from this file. Now, you're normally not going to do this with text or a little tiny file like this. What you might do, though, is want to write this from a Python script. And as we get to work with raster data, you'll also learn to do this using SPAPI and potentially writing your own raster transforms. And to do that, you've got to be able to get to this raster data. I do use ASCII grids once in a while, but usually I use formats like TIFF and IMG. Okay, so moving on to the next section, we get the code for how to write an ASCII grid file. And again, I'm going to pull the absolute path, and you can see that this is very simple. And first I'm going to set up my folder, make sure the code works. And you can see that this is missing something, okay? So this is just going to write out the header, and it went ahead and worked. Very simple, right? We open our file, we write out the number of columns, write out the number of rows. You can see this is 10 by 10. And then we write out the lower left corner, X and Y, and then the cell size, 1 for whatever spatial reference it is, and then our no data value. Okay, so now what we want to do is we're going to go borrow the code from 3.4 to write out 10 rows and 10 columns of data. So if we go back, remember, whoops, this code. There we go. Remember this code that did these 2 while loops? Okay, we're going to take that. We're going to paste that in. Okay, now we don't want to reopen the file again, but notice what this is going to do. This is going to go into our loop, and it's going to loop 10 times, once for each row. So from 0 through 9, won't do 10, 0 through 9 will be 10. Okay, it's going to do our /n. Now the problem is, well, first, we're going to have to do 10 columns instead of 4, okay? And we can write out an interesting value here, but we don't want this to be a comma. We want it to be a different delimiter, because ASCII grid files do not use commas, they use spaces, okay? And then we're going to close the file. So let's go ahead and run this. And it's going to run really quick. Wow, that was it. Really? That's all it took to run that. Like blindingly fast. And let's go ahead and right click and open our file with Notepad. And for CSVs, ASCII grids, a lot of other text files, I really recommend you do this, because notice that it didn't actually work. Okay, why didn't it work? Oh, because it's called something different. It's called gradient.asc. Okay, yay, there's our file. So, yeah, we haven't got a real coordinate here for X and Y, but that's okay. If you were doing this for real, you'd want to put one in. And I'll go ahead and remove the other layer and close Notepad, go back here, go to there, have it load, zoom to the layer. Ooh, and there's our kind of cool gradient that we created with Python code. Okay, You can see that what happened, we were writing out the row and column up here. Those values are near 0, okay, because we set the value based on the row times the column. As the row and column increased, we went from 0 here to 100 here. Whoops. Now it's putting pixel value there. Wow, that is just kind of messed up. 81. Oh, 81, because it's 9 times 9, because we never get to 100. Okay, so different values, combinations of multiplying the row index times the column index. So we could change this. We could do all kinds of things to do cool designs in ASCII grid files. You can up the number of rows and columns. You just need to remember when you change the loops here to increase the number of rows and columns in the data, you're also going to need to increase it here so that when ArcGIS or your other favorite GIS package reads the file, it knows to go ahead and do the right number of rows and columns. So those have got to be linked together. Okay, so have fun with that. Now, let's see. There is another way to do this that, depending upon what approach you take for the assignment, you may want to do. And the other approach is that instead of doing it this way, okay, and doing the loops inside of loops, which is valuable and kind of fun, the other thing you can do is you can just go the file.write, okay, and you could go 1 space 2 space 3 space 4 space 5. I am not going to write all these out. Oh, remember the /n, that's important. Instead, I'm going to make this 5 columns by 5 rows, and I will just go like that. I'll let test2.ascii run that, and you can see these are really fast, except here I have a problem. Oh, because I misspelled the file. It happens. Typing errors. Stop. Run. Okay, that's done. And I can now drag and drop that into Arc. And there's that file. So you can see that it's, wow, Esri just did a really bad job with the coloring there. That's quite strange. But anyway, the numbers are correct. 1, 2, 3, 4, and 5. ArcGIS Pro has obviously some issues. This is if you want to do something like do a picture or specific values, you could write each one instead of doing it inside of a loop inside of a loop. Okay, so have fun with that.